Hi there, this is part two of our essential functions videos. So for this example, we want to find an equation of the quadratic shown below. So I have 3 points and I know it's a parabola, it's a quadratic function. So we know from our prior knowledge in various classes that any 2 points define a line, any 3 points define a parabola. So let's find the equation of a parabola. Our general equations of the parabola are we have y equals ax squared plus bx plus c. That's the standard form of a quadratic, but we can also use the vertex form, which is ax minus h squared plus k. Okay, this is the vertex form because it gives us the vertex. The vertex is the point h comma k. The opposite of whatever is in there. So we can use either of these two to find the equation of the parabola. We can only really use the second one if we have the vertex. Otherwise, I can't really use it. If I don't have the vertex, I will use the top one. Do we have the vertex here? So the vertex of the parabola is the point right in the middle. So we do have it. So this is the vertex. So I could use that one. So let's try it. So using y equals ax minus h squared plus k, we know that the vertex hk in this case is going to be the point 1, negative 2. Which means that so far I have y equals, and we'll change this to f of x or g of x or whatever name we want to call it when we're done. So x minus h, so h is 1, and then square plus k, so minus 2. K is negative 2. And so now I need to find what is the value of a. So how do I find that? Well, I have two other points that I can use. So because 0 is nice, anytime I have 0 available, I'm going to use that as a point. So I'm going to choose the point 0, negative 1. Either point you choose to use should work, but just be nice to yourselves and pick the one with 0. So I'm going to have, this is my x and this is my y. So that means that from this step, I'm going to have y, so negative 1 equals a, x, which is 0, minus 1 squared minus 2. So I have negative 1 is equal to a times 0 minus 1 is negative 1, square is just 1, so a minus 2. Add 2 to both sides, so a is 1. And so now I can finish our equation. So I can say, therefore, those little dots in the triangle, it means therefore, y equals, so I can call it f of x, is equal to a is 1, so I'm not going to write it, so it'll be x minus h, x minus 1 squared minus 2. Because a is 1, we just put it there as an invisible one, and that is our function. Now what if you didn't have the vertex? We can use this equation of a quadratic in standard form to find it. So notice that I still have the y-intercept, so I know the y-intercept is 0, negative 1, so I can use that to tell that the value of c is negative 1. So let me see if I have one here. Yes. So using y equals ax squared plus bx plus c, and knowing that we have the y-intercept of 0, negative 1, yes, 0, negative 1, we can say then the equation becomes y equals ax squared plus bx minus 1, right? When x is 0, a and b go away, you're left with c equals negative 1. So far I have that. So now, how do I find a and b? We will use our other 2 points. So we do have the vertex and we have negative 1, 2. But remember, we're doing this, if you didn't have the vertex, you wouldn't be able to do it this way. So that's why we're using the standard form. So if this point 1, negative 2 was not the vertex, there are still 2 points that I know. So I have negative 1, 2, and 1, negative 2. So what can we do with those? So with the point negative 1, 2, again, that means this is x and this is y. Then we will have y equals, so that means 2 equals a x squared, so negative 1 squared, plus bx minus 1. And then solve that. So I have 2, negative 1 squared is just 1, so I have a minus b minus 1. Sorry, I wrote a c there. That should be a 1. And add 1 to both sides, or just leave it. If you wanted to, you could just to have a minus b alone. But now with the other point, with the point 1, negative 2, I do the same thing. So I will have y is negative 2, so negative 2 equals a times x, which is 1 squared, plus b times 1 minus 1. And so we have minus 2 equals a plus b minus 1. So notice essentially I have created two equations that have a and b. So I can put those together to create a system of equations. So I'm going to have 2 equals a minus b minus 1, and negative 2 equals a plus b minus 1. And so I have a system. The nice thing about this is that a and b already have opposite signs, so I can add them and those cancel out. So minus 2 plus 2 is 0, and I have a plus a is 2a, and minus 1 is minus 2. And so from here, solve for a. So add 2 to both sides, so I'll have 2 equals 2a, which means a is 1. And now that I have a equals 1, you can take that and plug it into any of these two equations in the system and solve for b. So if I choose the bottom one, so I'm going to plug in a equals 1 in here. So I'm going to have minus 2, sorry, this is getting a little messy. A is 1, so 1 plus b minus 1. And so notice that here when I combine like terms, 1 minus 1 is 0. So I just get b is equal to minus 2. So back to our equation, we had y equals ax squared plus bx minus 1, because we knew the y-intercept. We just solved for a and b. So a is 1, so I'm going to have y equals 1, so just x squared. B is negative 2, so minus 2x minus 1. And this will be, I got to my second example there. So this will be the equation of the quadratic. Is it the same as what we got up here? Well, this one is in vertex form. So what you can do is try to see, are they the same? Right? X squared minus 2x minus 1 is in standard form, and this is in vertex form. So if you square this out, so I get x squared minus 2x plus 1 minus 2, you FOIL that out, and notice that now that becomes x squared minus 2x, positive 1 minus 2 is minus 1. Are they the same? Yep. And so those are two ways that you can find the equation of a parabola. Which form you use, the standard form versus the vertex form, really depends on, do you have the vertex? If you have the vertex, then the vertex form is nicer. But if you don't have the vertex, then you use the standard form. Chances are you're going to end up having to create a system of equations. All right, let's try the next example, which is find a formula for a cubic function if all that is true. So we have, in this case, we are given the 3 zeros. So notice that this essentially is describing the x-intercepts of the function. So the function crosses the x-axis or the y-axis are at 3, at 1, and at -2. So those are the zeros of the function. So that means that if f of -2 is 0, that means that x minus x plus 2 is a factor. I was going to say x minus a minus 2, right? Because if you have, if a is a 0, then x minus a is a factor, right? So in this case, -2 is a 0, so that means that x minus a minus 2 is a factor. And we can do the same thing with the other ones. F of 1 equals 0 means 1 is a 0, so that means x minus 1 is a factor. And same thing with 3. F of 3 equals 0 means that x minus 3 is a factor. Now this I can't really do much with, but the fact that I have 0 here is what allows me to say this. So our function so far, we know that it's a cubic function, is going to be, I can say f of x equals, and I am using green. Please let me know, I just kind of chose it randomly, if green is something that I shouldn't use. I know sometimes some colors are not the best for everybody. So I'm going to have a times my factors. I have 3 factors, x plus 2, x minus 1, and x minus 3, right? Because I don't know what the leading coefficient is. And so that's where this next part comes in. F of 2 equals 8. So now I can use that. So using f of 2 equals 8, right? That means that when x is 2, y equals 8. So we can put that in here. So f of x is just a fancy name for y. So I have 8 equals a times x plus 2, but I should be plugging in what my x is. X is 2. So for every x, we're going to plug in 2. And y is 8, just to be consistent there. So I'm going to have 2 plus 2, which is 4, 2 minus 1, which is 1, and 2 minus 3, which will be -1. And so what does that give us? 8 equals 4 times 1 times -1, so -4a, which says a is -2 once you divide both sides by -4. So a is -2, so finally our function, so therefore f of x is a, so -2 times our zeros. And there you go. Just to double check, right? Set it equal to 0. And do we get the same things? So you will have 0 equals -2, x plus 2, x minus 1, x minus 3. Notice that then x will be -2, x will be 1, x will be 3, which are what these are, our zeros. So when x is -2, 1, and 3, we get the y value is 0. And then plug in x equals +2 in here, and you should get 8. All right, so I hope that this is helpful, and as always, email me if you have any questions.